A logarithm is another name for an exponent. So let's remember a little something about exponents. Remember that an exponential expression such as a raised to the n power means that we use a as a factor n times. So for example, if y equals 7 to the 5th, that means that we need to use 7 as a factor 5 times. 7 times 7 times 7 times 7 times 7. Now, the logarithmic form is just another way to express this same idea. Okay? And in the logarithmic form, we write the word log, which abbreviates the word logarithm, and then a little subscript 7 here, which lets us know what the base is. And then we write equals 5 on the other side. Notice that's where the exponent appears, on the other side of the equation. And then the y goes in between log 7 and the equal sign. Now these two forms are equivalent, which means that we can convert back and forth between the exponential form and the logarithmic form. So let's get a little practice doing that. 3 to the 4th power equals 81. Okay, so we see that the base is 3, so we're going to write log and then subscript 3. On the other side of the equation, we're going to write equals 4. That's the exponent. And between the log 3 and the equal sign, we're going to write 81. So there it is. Log the base 3 of 81 equals 4. Next example, we have 2 to the 6th power equals 64. Okay, so the base is 2, so we write log subscript 2. And then on the other side of the equation, we're going to write equals 6. That's the exponent. In between the log 2 and the equal sign, we write the number 64. So there it is. Log to the base 2 of 64 equals 6. Next example, we have 5 to the 7th power equals 78,125. Base is 5, so we write log subscript 5. And then 78,125 equals 7. Okay, next example, we have 10 to the 5th power equals 100,000. So log to the base 10 of 100,000 equals 5. And of course this works with variables as well. So if we have a to the n power equals y, then log to the base a of y is equal to n. Okay, going back the other way, if we want to convert from logarithmic form to exponential form, we first need to identify the base, which is the little subscript, and then the exponent is found on the other side of the equation. The other side of the equal sign, that's where the exponent is. And then the number between log to that base and the equal sign is what you're going to write on the other side of the equation in the exponential form. So for example, we have log to the base 2 of 32 is equal to 5. Probably you can see what you need to write here. 2 to the 5th power equals 32, right? There it is. Log to the base 6, 1296 equals 4. Again, we need to look at the subscript to get the base, look at the other side to get the exponent. So we have 6 to the 4th power equals 1296. There it is. Log to the base 9 of 3 equals 1/2. Okay, so following along, we know that the base is 9, the exponent is 1/2. We have 9 to the 1/2 power is equal to 3. And you'll remember that the half power has the same interpretation as the radical sign.